Okay, why you might need shared state in an object model, which is a class. Well, so what is shared state? Shared state refers to a situation where multiple parts of a program access and potentially modify the same data. In the context of Swift, shared state typically occurs when multiple instances or parts of the code hold a reference to the same class object. Changes made to that object by one part of the program are reflected everywhere the object is referenced. Why you might need shared state in an object model. you know, and that object model is a class, not a struct. Well, shared state is useful when your program requires one central source of truth for a piece of data that is accessed or modified by multiple parts of the application. This is where classes excel due to their reference semantics. All references to a class instance point to the same memory location, so changes made by one reference are immediately visible to others. Common scenarios for using the shared state: centralized data management. Example, a user session class that tracks whether a user is logged in. When multiple parts of an app need access and update the same session information, a shared state makes it easy to coordinate. Shared mutable state across threads. If a background thread processing data while the main thread displays it, shared state allows both threads to operate on the same object instance. Okay. So in this case, we're talking about downloading and updating a shared model, which we will have an example of that. Updating a shared model. Cache or singleton patterns. Classes work well when implementing patterns like singleton, where a single instance is globally accessible and holds shared data. And then there are relationships between objects. In complex object models with relationships, shared state ensures that modifying one part of the relationship is reflected everywhere. Okay, so let's why structs don't support shared state. Structs in Swift use value semantics, not reference semantics, meaning every time a struct is assigned to a variable, constant, or passed to a function, a new copy is created. Changes made to one copy are not reflected in others. This makes structs unsuitable for shared state scenarios because number one, independent copies. Every assignment or parameter passing results in a new copy, meaning there's no central object to update or synchronize. An immutable design. The structs are often used for immutable data. If your object model changes frequently or has relationships, managing shared state with structs can become cumbersome and error prone. When to use structs instead of classes. Structs are ideal when you don't need a shared state. The data model is simple, immutable, or thread safe. You want to avoid unintended side effects. You need shared state in an object model class when multiple parts of your app must access or modify the same instance of data, ensuring that updates are consistently reflected. Classes provide that flexibility and power of reference semantics for such use cases. On the other hand, structs are better suited for independent state scenarios where immutability, thread safety, and avoiding side effects are priorities. So now we're going to look at a code example. So here we go. We have two objects, and they're both classes: word forms and LF. And of course, you may be familiar with these because we've been working with these objects, except they've been structs. Now they're classes. So that means we have to add an initializer to both. Otherwise, they're identical to the structs. Um, and right here we have a function called parse word forms, where basically we accept a string, a JSON string, and the JSON string we turn it into data, UTF-8, right? That's data is passed to JSON serialization.json object data, and it will return what it will return is a dictionary of string as a key, and the value will be any. Okay. And we get a dictionary. Now what we want to do is we want to go to this dictionary and parse it, right? We have SF and LFS array, right? Just like here. We go up here, SF, LFS array, right? We have this array, and of course we have this is empty, but then we go through the dictionary, the array. How many dictionaries in the array of dictionary, right? Because that's what we have. An array of LF, right? It hasn't been parsed yet. So using the object model, we just create the objects, okay? So we do this right here, right here. So we aren't yeah, we're basically populating it using dictionaries. And now we go here, and then we return word forms, right? Right? And of course, word forms, this is the constructor. That's why we have an array of LF and SF. Go down here, an array of LFS. It's LFS. It's an array of LF and SF. Okay, this is the actual data. So really, we have two LFS and only one SF. Okay, now we're passing this to here, right? Because this is parse words form, this function up here. Okay, and if you notice right here, words form, LFS, the first frequency, which is 10. Okay, and this is the value that we have, 10. And then when we get into this thread, that's where things change. Now, you got to remember, we said this before, earlier in the slideshow, that when we have a struct inside these queues, these are individual different copies, right? This right here is a separate copy from this. Okay. These are all separate copies. Why? Because they're inside of queues. Okay. And as such, they're treated separately. However, since they are classes, these are all referencing the same word forms. They're all one. They have a shared state, and they're all pointing back to the same original word forms, right? Which is this, right? All of them. So when I modify this right here in this one, I'm modifying all of them. Every word form, right? All the word forms, right? But so let's run this 10, and then right here I added 5 and then 515. And then right here, it just throws what I have, 15, right? And so if these objects were structs, they would behave differently, right? I would only be able to, if I added 10 to 5, guess what? It would just be 15. Then I go back here, and this would just be 10. But they aren't. They're all pointing to the same reference. And that's the difference between classes and shared state and structs and by value or copies. That makes sense. So yeah, I just wanted to clear that up because a lot of people talk about it, but they don't really make it crystal clear. All right, on to the next.